Electrical load calculations are a critical aspect of designing electrical systems for industrial facilities. These calculations ensure that the electrical infrastructure can adequately support the power requirements of the facility's equipment and processes. Here's a detailed explanation of electrical load calculations for industrial professionals. 1. Understanding electrical loads. An electrical load refers to the amount of power consumed by electrical equipment, machinery, and processes within a facility. Loads can be classified into different categories based on their characteristics, such as resistive, inductive, capacitive, or a combination thereof. Industrial loads typically include motors, heaters, lighting, HVAC systems, control systems, and other machinery or equipment specific to the industry. 2. Types of loads. Continuous loads. These are loads that operate continuously at or near their full capacity, such as lighting, heating systems, or refrigeration units. Non-continuous loads. These are loads that operate intermittently or for specific durations, such as motors, pumps, or compressors. Peak loads. These are loads that occur periodically and require a higher amount of power, such as during startup or peak production periods. 3. Determining load characteristics. Industrial professionals need to gather information about the electrical equipment and processes in the facility, including their power ratings, operating schedules, duty cycles, and starting currents. They may conduct site surveys, review equipment specifications, and consult with equipment manufacturers to obtain accurate data for load calculations. 4. Load calculation methods. Manual calculation. This involves calculating the total power demand of individual loads and aggregating them to determine the overall electrical load. It requires knowledge of electrical principles, equipment ratings, and load characteristics. Software tools. There are various software tools available that can automate load calculations based on input data and predefined algorithms. These tools can streamline the calculation process and provide accurate results quickly. 5. Factors considered in load calculations. Diversity factor. The ratio of the sum of the individual maximum demands of various loads to the maximum demand of the entire system. It accounts for the likelihood that not all loads will operate simultaneously at their maximum capacity. Demand factor. The ratio of the maximum demand of a system or part of a system to the total connected load. It considers the actual power demand compared to the maximum capacity of the electrical system. Power factor. The ratio of real power, kW, to apparent power, kVA, in an electrical system. It accounts for the reactive power component and influences the sizing of transformers, cables, and other equipment. 6. Load balancing and distribution. Once the total electrical load is calculated, industrial professionals need to distribute the load evenly across the electrical distribution system to prevent overloading of circuits, transformers, and other equipment. Load balancing involves allocating loads strategically and optimizing the layout of electrical panels, subpanels, and distribution boards to ensure efficient power distribution and utilization. 7. Compliance with standards and regulations. Industrial professionals must ensure that electrical load calculations comply with relevant standards, codes, and regulations governing electrical installations and safety practices in their region or industry. Standards such as the National Electrical Code, NEC, International Electrotechnical Commission, IEC standards, and local building codes provide guidelines for electrical design, load calculations, and equipment selection. By conducting accurate electrical load calculations, industrial professionals can design electrical systems that meet the power requirements of industrial processes while ensuring safety, reliability, and efficiency in operation. These calculations are essential for sizing equipment, determining wire sizes, selecting protective devices, and optimizing the performance of electrical installations in industrial facilities.